What is a 3D surface plot? Whether you need good help, a genius writer, a brainy tutor, or a data wizard, Intuito4U has them all. It's like having a research dream team on demand.
Have you ever been staring at a spreadsheet, just drowning in columns and rows of numbers? You know there's a story in there somewhere, but it's impossible to see. Well, today, we're going to pull back the curtain on a really cool tool that turns that chaos into clarity. We're demystifying the 3D surface plot. Okay, let's just jump right into the core problem. We live in a 3D world, right? But our screens are paper. They're all flat. So how in the world do you show the relationship between three different things at the same time? A simple line chart can handle two variables, no problem. But when you add that third one, things get complicated.
And if you're looking at your data like this in a raw table, good luck. Your eyes just glaze over. You could have time, wavelength, and absorbance, but trying to find any real pattern in this wall of text, it's almost impossible for our brains to process. You just can't see the big picture. But what if we could take that mess of numbers and turn it into this, an intuitive visual landscape? This is the magic of the 3D surface plot. It literally sculpts your data into a story you can understand just by looking at it.
So what exactly is it? Simply put, a 3D surface plot is a graph that shows how three variables relate to each other. And the best way to think about it is like a topical map for your data. The peaks are the high values, the valleys are the low ones. It's that simple. All right, so how do we get from a boring table of numbers to this beautiful, complex landscape? To really get it, we need to kind of pop the hood and see how these things are built, piece by piece. It all starts with a skeleton. This wireframe you see here is the basic structure. It's a grid built from our first two variables. We'll call them X and Y. This lays the literal foundation for our data landscape. Next, we lay a skin, or a smooth surface, right over that skeleton. This surface connects all the dots, and its height at any given point is decided by our third variable, the Z variable. That's what gives it shape. And this is the final layer that makes it all click. We add color. A color gradient is mapped onto the surface, where different shades represent different heights or Z values. Suddenly, the whole thing becomes instantly readable. Your eyes can immediately find the highest peaks and the deepest valleys without even thinking about it.
So let's just recap real quick. You've got your two independent variables, X and Y, on the flat bottom plane. And how they interact determines the value of that third variable, which we see as the height on the vertical Z-axis.
Okay, so now we know how it's made. Let's get to the fun part. How do you actually read the thing? It's time to become a data explorer and find the stories hidden in that landscape.
Seriously, reading one of these is just like reading a map. Every little feature, every peak, every valley, every ridge tells you something important about how your variables are connected. You're basically looking for the key geographical features in your dataset. And this is where you can start spotting some really cool patterns. A peak? That's your maximum value. The sweet spot where X and Y combine to give the highest result. A valley, obviously, is the minimum. But then you get these fascinating things called saddle points. They're a minimum from one angle, but a maximum from another. Kind of tricky, but super insightful. Check this out. This shows the connection perfectly. On the left, the 3D plot is like looking at a mountain range from the side. On the right, the 2D contour plot, well, that's the exact same data, just viewed from directly above, like a classic trail map. They're two sides of the same coin, just different perspectives on the same story.
All right, but it's not all perfect. I have to be honest with you. For all their beauty, these 3D plots come with some serious hidden dangers. If you're not careful, they can actually mislead you.
In fact, you might be surprised to hear that a lot of data viz experts are really wary of 3D charts, and some even say you should just avoid them completely. So what's the deal? Why all the controversy?
Well, it boils down to two main problems. The first is occlusion, which is just a fancy word for saying some parts of your data can be hidden behind other parts. Just like a big mountain can hide a smaller one behind it. And the second, maybe even bigger problem is distortion. Perspective can trick your brain, making faraway peaks look smaller than closer ones, even if they're actually the same height. This example just drives the point home perfectly. Look at that 3D bar chart. Can you tell for sure if bar D is taller than bar F? It's really hard, right? The perspective messes with you. Now, look at the simple 2D version. The answer is obvious in less than a second. In this case, the 3D didn't add clarity. It just added confusion.
So does that mean 3D plots are useless? No way, not at all. The secret weapon, the solution to these problems, is interactivity. If you can grab that plot with your mouse and spin it around, look at it from any angle, well, then you can peek behind those hidden mountains and overcome the distortion.
And that whole idea of interactivity, that's the key, because it really points to where all of this is going. So let's wrap this up by looking at what's just over the horizon. So what are the big things to remember? 1. 3D surface plots are a fantastic tool for seeing three variables at once. 2. That topographical map idea is your best friend for understanding them. 3. You have to be careful. Watch out for distortion and hidden data. And finally, remember that interactivity isn't just a nice little feature. It's absolutely essential for seeing the true picture.
The future for this kind of thing is just mind-blowing. We're already starting to move beyond our flat screens. With things like virtual and augmented reality, we're going to be able to stop just looking at our data landscapes and actually start walking through them.
And that leaves us with one final big question to think about. When our data isn't trapped on a screen anymore, when we can literally step inside of it and explore it like it's a real place, how is that going to change the kinds of stories we find and the discoveries we make? Now that is a future worth visualizing.
And subscribe now for amazing videos just like that. Thanks for watching.